Why do you do that?
Do you want to know who this belongs to? It's Ariane's. I'll give it to him.
Tyler. Do I need to remind you about my
No, I'm just gonna leave it.
Are you related to the more or less?
Maybe remind me of
Those are nice
Okay, let's get going. Number 11. Okay, 11. We did this in class, so I'm hoping this is going to go quickly. Number 11. So we got our boat being pulled in. And this is 20, and this was 16. This was currently 12, and it's decreasing there. That's going that way at 50. Yeah. And so we have x squared plus y squared equals z squared. X squared is not constant. Y squared is constant. Z is also not constant. We'll take our derivatives with respect to t. And that gives us 2x dx dt equals 2z dz dt. Substitute your numbers in. 2 times 12 times dx dt equals 2 times 20 times negative 50. And that gives you some number. I don't know what the number is. 1.993? 84.666. Yeah.
Is it 28? Is it dx or 2x times dx dt equals 28?
20.
2z.
Where? Here?
Yeah.
Z.
Okay.
$83. 3. Okay. So that's a typo here. Just trying to fix the typos for next year. Okay. Question 1. GT is 1/4 t cubed plus 16 over t. So we want the differential. So y is equal to 1/4 t cubed plus 16t. dy dt is 3/4 t squared minus 16 over t squared, which means dy is equal to 3/4 t squared minus 16t squared times dt. Substitute junk. and you get six squared and that should give you the answer, which is negative 13.277, unless there's a typo.
That's right.
That's part A. Part B, tangent line approximation. So our tangent line, we need an x, we need a y, we need an m. X, they give you a 6. Y is 1/4 of 6 cubed plus 16 over 6. M is 3/4 of 6 squared minus 16 over 6 squared. Let's get these numbers. The first one, 1/4 times 6 cubed plus 16 over 6. Notice my old calculator doesn't have nice pretty print. Let's store that as B. 56.666. Next one. I have 3/4 times 6 squared minus 16 over 6 squared. And let's store that as m. 26,555. Excuse me 1 minute. What was the answer to 11? The 83. All right, and let's calculate then g of 5.3 can be approximated by 26.5556. 5.3 minus 6 plus 56.6667. Where you write it down, but you don't actually calculate. I'm going to do that now. We're going to make it m times 5.3 minus 6 plus b, 380777. And that's it for part B. Questions? Okay. How about 2? Oh, part C. Sorry. Part C. Well, let's see. What is G double prime? G double prime is 3/2 times t plus 32 over t cubed, right? Okay, and so there was a lot of talk about, do I substitute 5.3 or do I substitute 6? And you should substitute at the point of tangency. So that's 6. G double prime at 6. Okay, that looks like 6 at 6. Is equal to 3/2 times 6 plus 32 over 6 cubed, which is greater than 0. I really don't care what the number is. I'm really interested in positive or negative. So that means the function's concave up So in other words, I have a function that looks like this, and no matter where I draw that tangent line is going to be an under approximation. Okay. The tangent line under approximates a concave up function. Yeah.
So would the compute error approximation just be the answer of what the second derivative is?
Error of approximation is equal to the actual value minus the predicted value. So what is the actual value? The actual value is 1/4 of 5.3 cubed plus 16 over 5.3. $40.238. $117 minus my predicted value. My predicted value was 38.077. So we can just calculate that. We'll take the answer. Take the answer minus 38.07777. So the error looks like 2.1603. I forgot already. 1603.
Do you want us to do this on test?
If you're asked, yeah.
I don't really get what this is.
What do you mean?
What is like the error and
Well, we made it.
what
We
error are you finding?
we made an estimate of 5.3, right?
Yeah.
we have the luxurious position to actually know what the true value of g of 5.3 is. Okay. And so if we know what we predicted, and if we know the actual value, then we should be able to figure out how off were we. Okay. This says our prediction was about 2 units lower than it should have been. It's possible. I mean, what's g of 5.3? You have an equation for g. You should be able to just crunch that out. Okay? All right. Should we do 2? I think that was a yes. Number 2. We'll try and do this briefly. Okay, so we have our pens. We have 4 x's and 2 y's. And so we have 4x plus 2y is equal to 1,000, or y equals 500 minus 2x. We want to maximize the area, so xy is going to be my f. And that's going to be the same thing as 500x minus 2x squared. We want to maximize, so we need a derivative. F prime of x equals 500 minus 4x. Give me a critical number of x equals 125. Okay, now we need to check to make sure that that critical number is actually a maximum. So we'll need limits on x. The smallest x could be a 0. Because I have 4 x's, if all 4 x's take up the fence, then each x should be at 250. So that's my minimum and my maximum for x. We're going to do a candidate test. X, f of x. If x is 0, the function gives me 0. If x is 250, the area function gives me 0. And if x is 125, the area function gives me 31,250. So these are mins. This is max. And we can say maximum area of 31,250 occurs when the pen has dimensions 125 by 250 feet. How'd I get that 250? Yeah, we just plug that in. If you remember, y was equal to 500 minus 2x, then y is 500 minus 2 times 125. And that's all of 2. How about 3? Okay, we have our cone. That's a pretty good cone. The radius is 2. So the radius to height ratio is 2 to 6, meaning the radius is 1/3 of the height. That changes our volume formula. Previously our volume formula was 1/3 pi r squared h. After you make the substitutions, we get the volume is 1/27 pi h cubed. Currently, h is 3, so the current volume is equal to 1/27 pi times 3 cubed, which equals pi. dV dt is 1/27 times pi times 3h squared times dH dt. That simplifies. dV dt is equal to 1/9 pi h squared dH dt. Substitute stuff. dV dt is -1/2. H is currently 3. So that tells me dH dt is equal to -1/2 pi. So we can write down the height of the liquid is decreasing. Hello. At a rate of 1/2 pi bless you. Inches per minute. Yeah, that's it. And now we got the last one. Okay. All right, so here's my pipeline. You know what? Let's add some color to it. Here's the pipeline. So we got to figure out how long this piece in the water is, and that happens to be the square root of 9 plus u squared. This piece over here is 5 minus u. And so the cost is equal to 4 times, no, it's not 4, is it? Because we're in miles. So $4 per mile. No, yep, per foot. That's the same thing as $21,120 per mile. And then $2 a foot that's equal to $10,560 per mile. So the cost is $21,120. 9 plus u squared plus 10, 5, 60 times 5 minus u. And we'll just make that equal to f. Yes?
Did you plug in the $4 into the 9 plus squared?
I multiplied the 9 plus u squared by the cost per foot.
How did you get that? Like, how did you get the
The amount of feet is square root of 9 plus u squared.
Okay, so you plug in 4 and then
Well, it's $4 a foot. And $4 a foot is equivalent to $21,120 per mile. The problem is our diagram is in miles, but our rate is in feet. 5,280 feet per mile. So we're changing everything into miles. Okay, so we're going to take our derivative so we can figure that out. So what is this derivative? 21,120 times 1/2 9 plus u squared to the negative 1/2 times 2u minus 10,560. Which simplifies to 21,120u minus 10,560 root 9 plus u squared over root 9 plus u squared. And now we're supposed to find critical numbers. 21,120u minus 10,560 root 9 plus u squared. Set that equal to 0. And then solve with your calculator. I'll do that real quickly. You can. Okay, so let's clear things out. $21,120 x minus 10,560 square root of 9 plus x squared. Set that equal to 0. I'm going to zoom 6 and get this. Okay. And x equals 0. If you have the color one, you know that x equals 0 is this horizontal line here. And then we can just find our intersection now. Second, calculate an intersection. I'm just going to push enter 3 times, and that gives me 1.73205. 732.0508. Okay, do I know that that's a minimum? Could be a maximum. So what we're going to do is we're going to do a quick candidate test. Let's figure out a domain for u. The smallest u could be a 0. And back to here, what's the biggest that u could be? Looks like the biggest u could be is 5. So in our candidate test, we're going to put 0, we're going to put 5, we're going to put 1.732. I'm going to use this number later. It's still an x right now, but I want to take that and store it. Let's store that as a. And let's remember what the cost function was. What was our cost function? Our cost function was 120 times the square root of 9 plus x squared plus 10,560 times 5 minus x. Right? So let's figure out what is the cost. So we're going to do var. Well, we've never done this before, have we? So the cost at x equals 0 is 116,160. This equation. Okay, let's find y1 at 5. 1, 2, 3, 1, 4, 9, 704. And lastly, let's figure this out at A. 107,671. Point 396. 369? Oh, yeah. All right, so based on this evidence, I see this is the maximum and this is the minimum. So the minimum cost is $107,000. $671.37 when the pipe reaches land at a point 1.732 miles from point R. And that's that. That's so exciting. Yeah.
Are we only going to need to know like miles to the year, or do we have this sort of all the way?
Well, I don't expect you to know everything. But I do expect some basic ones. Feet to inches, inches to foot, miles to meters to kilometer. I can't think of more right now. Yeah.
What's the conversion factor for miles to feet?
5,280 feet is 1 mile.
Can you repeat that?
5,280 feet is 1 mile. Okay, any other questions? Mm-hmm.